Welcome to springlib.
We're asked to find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. So we have our circle of radius r, and we have a rectangle inside of this of maximum area. Now, we have the area of such a rectangle. If we call the length of one side x and the other side y, is going to be x times y. Now notice that we can also draw a point from the center of the circle to one of the corners of the rectangle, which has a length between them, a segment of length r. So by Pythagorean theorem, we have that half of the length of one side, x over 2 squared, plus half of the length of the other side, y over 2 squared, is equal to hypotenuse r squared. In this way, we have a relationship between x and y. Now, to help us, notice that our function area is always greater than or equal to 0. Well, we can't quite do that. But notice that both x and y have to be greater than 0. So we can solve for y in this equation. We have y over 2 squared equals r squared minus x over 2 squared, so that y over is equal to 2 times the positive square root of r squared minus x over 2 squared. And therefore, the area as a function of x is x times 2 times the square root of r squared minus x over 2 squared. So now we want to find the maximum value of a. Notice that x and y are both also less than r. So to do this, I'm going to find the derivative. A prime of x, this is going to be, well, before we even do that actually, notice that a is of course always greater than or equal to 0 on 0 to r, and that a therefore has a maximum when the function f, which is a squared, is maximized. Now f of x, this is equal to 4x squared times r squared minus x over 2 squared. Now, to find the maximum of f prime of x is, by the product rule, this is 2 times 4, 8x times r squared minus x over 2 squared, plus 4x squared times the derivative. The second factor, this is negative 2x over 2 times 1/2. We're going to set this equal to 0 to find the critical values. So we have 8x r squared minus 8 over 4 is 2x cubed plus, let's see, this is negative 4 over 2 is negative 2. And this is, again, x cubed equals 0. So we have positive, sorry, this should be negative 2x cubed. So positive 4x cubed minus 8r squared x equals 0. We can solve by factoring. We get 4x times x squared minus 2r squared equals 0. This can also be factored as 4x times x minus root 2r times x plus root 2r. And so the solutions and our critical values are x equals 0 and x equals plus or minus root 2r. Now, to determine for which of these critical values f is maximized, subject to x between 0 and r, well, first of all, plus or minus root 2r is already not an option. I'm sorry, I made a mistake here. X should actually be between 0 and 2r. So while negative root 2r is not necessarily good, positive root 2r could work. So we're really just looking at positive root 2r and 0. Now the second derivative, f double prime of x, this is 8r squared minus 12x squared, which if we plug in 0, f double prime of 0 is 8r squared, which of course is positive, and f double prime of root 2r is 8r squared minus 12 times 2r squared, which is negative 16r squared, which is less than 0. Now, because the second derivative of f at 0 is positive, it follows that f has a local minimum at x equals 0 and a local maximum at x equals r root 2. Because, well, now we need to compare the values of x equals r root 2 and 2r. So we have f of 2r so this is on 0 to 2r. F of 2r is 4 times 4r squared times r squared minus r squared, which is 0, while f of r root 2, this is 4 times 2r squared times r squared minus root 2 over 2 squared, which is 1/2 r squared. This is 8r squared times 1/2 r squared, which is 4r to the 4th, which is positive. Therefore, it follows that f has an absolute maximum on the interval 0 to 2r at x equals root 2r. Now to find the other dimensions of the rectangle, we know that y is going to be 2 times the square root of r squared minus x over 2 squared. So this is 2 times the square root of r squared minus root 2r over 2 squared, which is equal to 2 times the square root of r squared minus 1/2 r squared, which is 2 over root 2 times r, which is the same as root 2r. Therefore, the dimensions are x equals r root 2 and y also equals r root 2.